Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module, that is a database design concepts, and the same chapter, that is chapter number 5, Advanced SQL. In the last class we have started with this chapter, that is Advanced SQL, and we have covered the ODBC and the basic concepts of the Advanced SQL, as well as the JDBC of the Advanced SQL. Then I will continue this chapter in the today's class also, that is what are the various SQL functions and the procedures that is used in the Advanced SQL. So let's start the chapter. Let's start with the previous class session, that is chapter number 5, that is Advanced SQL. Then moves to today's topic, what are the SQL functions and the procedure that is used in the Advanced SQL. So let's start the session, or let's start the activity with the previous class session. So in the last class we have started with chapter number 5, that is the Advanced SQL. So chapter number 5, that is Advanced SQL. So we have studied in chapter number 3 and 4 about the introductory SQL, that is the introduction to the SQL, as well as the intermediate SQL. And in this chapter, this is a chapter that is talking about the Advanced SQL, that is how to use the Advanced SQL, or what is advanced SQL, but what does it contain, and what are the various categories of the advanced SQL, right? So SQL is also used with the general purpose programming languages like Java, like C, like C++, like Prolog. So we have to use the Java, we have to use the C++ with the programming or with the database that is done by the various concept that is covered in the advanced SQL. That is the various theory that we have studied about the introduction. So, and then we will discuss there is also a concept that is a OLAP, that is online analytical processing system, that is also available in this chapter. This topic is also available in this chapter. Then we have discussed about how to access the SQL from a programming language with the use of ODBC or with the use of JDBC. There are two concepts. One is the ODBC, that is the Open Database Connectivity. One is the JDBC, that is the Java Database Connectivity. So one is first is accessing SQL from a programming language. So SQL also provides a powerful query language. Writing queries in SQL is usually much easier than coding the same queries in a general purpose programming language. However, a database programmer must have access to a general purpose programming language for at least two reasons. That is, what are the two reasons? Why there is a need for the SQL? Why there is a need for the database for the with the programming language? Because whenever we write any program, then there will be a query that will be taking up, or that will be a fetching up, so that the query will be maintained, or we have to use the query by the using the SQL. So SQL also provides the full expressive power of a general purpose programming. Therefore, SQL is also used with the programming language to make the database, to follow the database, or to use the database that is used with the SQL. Then next is the non-declarative action. That is, if I want to print a report, if I want to interact with the user, sending the result of a query, that is also done, or this is also done by using the non-declarative statements. That is also done by using the SQL, that is a structured query language. So there are two approaches to access the SQL. There are what are two approaches? One is the dynamic SQL that contains the ODBC and the JDBC. One is the embedded SQL, that is embed the SQL, or simply put the code into the programming language to embed the SQL, to embed the database connectivity. A major challenge that is mixing SQL with the general purpose programming language is a mismatch in the ways these languages manipulate data. In SQL, the primary type of data is the relation. SQL statements operates on the relation and return the relation as a result. So whatever the SQL statement that is using, that is operate on the relation, that operates on the tables, and also returns the tables as a result, or also returns the relation as a result. So it also operates on the relation, it also returns the relation as a result. So, and then we talked about the JDBC, that is a Java database connectivity, that is used as a programming, or that is used as a API, that is an application program interface, that the Java programs can use to connect to the database server. So if our Java program needs to connect to the database server, that is done by the, or that is fulfilled by the JDBC, that is a Java database connectivity. This is the code that is given by the JDBC, that is the Java database connectivity. Then we have discussed about the how to connecting with the database. What are the various steps that is used in the database? This is the steps, that is we have to use the get connection, password, parameter, that is used with the JDBC. Then shipping the SQL statement to the database system, that is how to ship the SQL statements to the database system, or how to send the database connectivity, or how to use the program so that it will send the SQL statement to the database system for the execution. That is done by the instance of the program or instance of the class statement. A statement is the object is not the SQL statement itself, but rather an object that allows the Java program to invoke the method that ships an or that pass an SQL statement that is given as an argument for the execution by the database system. So there is a database system that shipped the SQL statement to the database systems. And then we will discuss how to retrieve the result of a query, that is what are the various methods how to retrieve them. So the example program executes a query by using stmt.execute query. The execute query command, or we can say the execute query keyword, is used to retrieve the result of a query, that is executing the query. It retrieves the set of tuples in the result into a result set object rset and fetches them one tuple at a time. So what does it contain? So it contains, or it retrieves the tuples, we can say the rows in the result, into a result set object rset and fetches them one tuple at a time. So fetching them the tuples one tuple at a time, that is also retrieving the result of a query. This is how we can say the program that is given for retrieving the queries. Then next is the prepare statement. That is, what is the prepare statement? How we are using the prepare statement. So we can create a prepared statement in which some values are replaced by the question mark, thereby specifying that actual values will be provided later. So we are also providing the question mark, that is condition is that the next value will be provided later, that is done by the question mark. That is a prepared statement. The prepare statement method of connection class submit an SQL statement for compilation. It returns an object of the class, that is a prepared statement. At this point, no SQL statement has been executed. That is, there is no SQL statement that has been executed. So there is an execute query, and the execute update method is also used with the prepared statement class. Then we will discuss about this one, that is how to instruct the queries or how to use the queries. Then these are the metadata function that is also available in the we can say the JDBC we have discussed. Then other feature, that is there is other feature, that is a updatable result set, that is JCBC or JDBC also provides the additional features, that is provide the up to date information, that is up to date result set, that is also available with the JDBC. It can create an updatable result set from a query that performs a selection or projection on database relation. So these are the various terms, these are the various functions that will be used. And JDBC also includes a row set feature that allows the result set to be collected and shipped to other applications. Then we will also discuss about the ODBC, that is Open Database Connectivity, that standard defines an API, that is the Application Programming Interface, that applications can use to open a connection with the database. So suppose if any application that is want to open a connection with the database, that is done by the ODBC. So if any connection is maintained with the database, that is done by the ODBC, and any open environment, any open programming language like C, C++, COBOL, any programming when connect with the database, that is known as the ODBC. So it's a standard API that applications can use to open a connection with the database, send the query, update, and get back the result. So first of all, open a connection, then sends the query, update, and then get back the result. Applications such as GUI is also used, that is a graphical user interface, to provide the connection between the databases. Each database system also supports the ODBC that provides a library that must be linked with the client program. And these are the various SQL fetch statement that is used with the while loop. So we are using the while loop in the program, that shows how to use the ODBC with the various features. Then we also discuss about the ADO.NET, that is what is ADO.NET, that is designed or that is used for the Visual Basic .NET. So ADO.NET also provides an interface or connectivity with the database by using the Visual Basic .NET command and the C# language, that is the C# programming language. Then we also discuss the embedded SQL, that is how to use the embedded SQL or what is the embedded SQL. So the SQL standards also defines the embedding of SQL in a variety of programming languages such as C, C++, COBOL, Pascal, or Fortran. A language in which the SQL queries are embedded is known as the host language. So whatever the language in which the SQL queries are embedded, SQL queries are inserted, that is known as the host language, and the SQL structure permitted in the host language constitutes the embedded SQL. Programs that can be written in the host language can use the embedded SQL syntax to access and update the data stored in the database. So whatever the data that is stored in the database, that is embedded with the embedded SQL. The preprocessor replaces the embedded SQL request with the host language declaration and procedure call that allows the runtime execution of the database access. Therefore, the resulting program is compiled by the host program. This is the main difference between the embedded SQL and the JDBC or ODBC. This is the syntax that we have discussed about the executable, or we can say the embedded SQL, that is how to embed the SQL in the server or how to connect with the server. These are the various terms. This is how to close, this is how to update, insert, delete. Then next is the functions and the procedure, that is what are the various SQL functions and what are the various procedure that is followed in the SQL, that is structured query language. So let's start with this session. Let's start with the today's session, that is the functions and the procedures. So we have already seen various features, several functions that could be or that can be built into the SQL language. So whatever the feature, whatever the function that is available that can be built into the or that are built into SQL language. In this section, we show how developer can write their own functions and procedures, store them in the database, and how to invoke them from the SQL statements. So functions and the procedures are also the business logic that is also available. This is we have not discussed. So what are the functions? So functions are particularly used with the specialized data types such as images and the geometric objects. So whatever the function they are created, that function is based for the or based on the specialized data types such as images and the geometry objects. For example, a line segment data type that is used in the map database may have an associated function that checks whether two line segments, it's okay delta, whether the two line segments overlap, and an image data type may have associated function to compare the two images for similarity. So there are various functions, there are various procedures that can be defined in the SQL statement or that can be defined in the SQL for making the comparisons. Then in the next paragraph it is said that the procedures and the functions also allow the business logic to be stored in the database. So whatever the business logic that is available, that is stored in the database. The business solutions or the business logics are provided or are we can say the stored in the database by the procedures and the functions and executed from the SQL statement. For example, universities usually have many rules about how many courses a student can take in a given semester. The minimum courses a full instructor must teach in a year, and the maximum number of majors a student uh, can be enrolled in, and so on. So what are the various features, what are the various functions, what are the various procedures? We can say the rules regulation that is used in the university that is followed by the functions and the procedures in the SQL. While such business logic can be encoded as a programming procedures stored entirely but outside the database. For example, it also allows multiple applications to access the procedures and allows a single point of change the business rule change without changing other parts of the application. So SQL also allows the definition of the functions, procedures, and the methods. So SQL also provides or also allows the definition of the functions, what are the various functions, what are the various procedures, and what are the various methods. These can be defined either by the procedure component of the SQL or by an external programming languages such as Java, C or the C++. So SQL also defines the functions, procedures and the methods, and they are defined on either by the directly the procedure component of SQL or by the external programming language like C or the C++. We look at the definition SQL first and then see how to use the definition in external languages. What is the use of the SQL in external languages? So although the syntax we present here is defined by the SQL standard, most database implement non-standard versions of this syntax. So whatever the syntax that is used, that is defined by the SQL standard, and whatever the database implementation, that is the database implements non-standard versions, is also taken by the database connectivity. For example, the procedural languages supported by an Oracle, that is a PL, and the SQL, Microsoft SQL Server and the Progress all differ from the standard syntax that we present. This is one of the function, that is a create function department count. This shows how to embed the function within the SQL. That is a function embed or defined in the SQL. So create a function department count. There is a department name attribute that is taken, and that is of varchar type, that returns some integer value. What is the begin? That is declare the d count as an integer, then select the count star into the d account from the instructor where the instructor or department name equals to department name, that is result the d count. Then there is a end. So first of all there is a function that is created, that is a department count, and then there is a returns in integer, that is it will give down integer value, then begin, then declaring, then selecting, then from, then where. So we illustrate some of the differences for the case of the Oracle later in this chapter. Although parts of the syntax we present here may not be supported on such systems, the concept we describe is the main limitation, that is how to use the functions or how to use the SQL functions and the procedures. Then the next is declaring and invoking SQL functions and the procedures. That is how to declare and how to invoke SQL functions and the procedure. That is how to use the SQL functions, how to use the SQL procedure, that is used with the SQL language, that is used with the programming language. Suppose that we want a function that gives the name of our department, returns the count of the number of the instructors in that department. So what does it mean? That is, it display what type of department it is, that is the name of a department, returns the count of the number of instructions in that department. We can define the functions as shown in figure 5.54. That is, this function can be used in a query that returns names and the budget of all departments with more than 12 instructors. So this is the, we can say that this is a figure that is given, that is a select department name budget. So there are two fields that is available, one is a department name, one is a budget, and from the table instructor where department count and the department name that is greater than 12 characters. So this is the query that is that returns the names and the budget of all the departments with more than 12 instructors. So if there are variable that is given, that is a instructor that is given, that is more than the 12. This is select department name budget from the instructor where department count, that is counting first of all department name, then that is greater than 12. The SQL standard supports functions that can be written the tables as a result, and such functions are known as table functions. There are some functions that gives the output in the form of a table, in the form of a, we can say the function in the form of a table, that is known as the table functions. Consider the function that is defined in figure 5.6. The function returns a table containing all the instructors of a particular department. Note that the function's parameter is referenced by prefixing it with the name of the function, that is an instructor of department name. The function can be used in a query as follows. So this is a function that is given that can be used in a query. What is the function that is available? This is select star, that is selecting all the fields or displaying all the fields of the table from the table that is the instructor of finance. This is for example. So this query returns all the instructors of the finance department. Whatever the instructor that is available in the finance department, that will become down, that will be catching up in the we can say the column heading. With the help of this, we can say the table functions. In the above simple case, it is straightforward to write this query without missing table value based questions. In general, however, table value questions can be thought of parameterized view, but generally the regular view of the is allowing the parameters. This is one of the best example. Another example, that is creating the function, that is the instructor of is the function name, then department name varchar, then returns the table. What does table contain? That is table contains the ID, name, department name and the salary. Then returns the table. Then what are the value that is given in the table? That is the ID, name, department name and the salary from the table instructor, where instructor dot department name is equals to the instructor of department name. SQL also supports a procedure. So we have finished with the function, that is how to use a function, what is the main usage of functions, then what is the procedure. The department count fraction could be so the SQL also supports the procedure, that is the procedure are also stored in the SQL. The department count function could be written or could be used instead be written as follows or as a procedure. So what is the same table, what is the same program that can be written as a procedure? This is create procedure department count proc in department name varchar 20. So what is the name of the procedure? That is a procedure. Then the department or create the procedure, that is the name is the department count proc, that is the department count procedure in the department name and the varchar. So what is the name that is given, that is stored in the department name. Then begin, then select asterisk into the D account from the table instructor, when instructor or department name is equals to that department count proc department name. So whatever the procedure that is given, that is used for the department name, that is showing the instructor, that is showing the various value that is given in the instructor. Therefore, the keyword that is available, that is the in and out respectively, showing the parameter. So what is the in and out? That is showing the parameter. In means inserting the data, out means displaying the output that are expected to have value that is assigned to them, and the parameters whose values are set in the procedure in order to return the result. Procedures can also be invoked either from a SQL procedure or from the embedded SQL by the call statement. So we can also declare the we can say the SQL or Oracle programming language by using the declare and the call. Function and the procedure can be invoked from dynamic SQL. SQL also permits more than one procedure of the same name. So more than one procedure can have the same name in the SQL, so long as the number of argument of the procedure with the same name is different. Although the name of the procedure is same, but the argument list that is given, that is the prototype that is given, that must to be changed or that must be changed. The name along with the number of argument is used to identify the procedure. SQL also permits more than one function with the same name. So it is given by the various argument, that is the same argument but the different the type of the at least one argument. So one argument is given different type, that is the main difference. Otherwise they have the same. Now next is what are the various language constructs that is used for the procedures and the function, that is what are the various language constraint, what are the language difficulty barrier that is available. So see, SQL supports constructors that is given its almost all the power of a general purpose programming language. The part of the SQL standard that deals with the fixed or these constructs, that is known as the primary storage or model storage. Variables are declared using a declare statement. So what's the statement that is used? That is using the declare statement to declare the keywords. That declare the we can say the variables, and can have any we can say the any SQL data types. Assignments are performed using a set statement. So of how the assignment will be performed, that will be performed by using the set statement. A compound statement is one of the form that is the begin and the end. So one of the compound form that is available, that is the begin and the end. This is one of the example that is used, that is a while boolean expression do sequence of statements. So what is the while condition? That is a boolean expression. What does it contain? The sequence of instruction, and there is a do block, and there is the end while. So what does that mean? This is the block that is used for both the boolean algebra as well as the sequence of elements. Then repeat, that also contains the sequence of instruction statements, that is a repeat, then until boolean algebra or boolean expression end repeat. So one is a while, that is the end while, one is a repeat, that is the end repeat. Therefore, there is a for loop that permits the iteration all over the or overall result of a query. So therefore, for loop is used to give the overall result of a query. So this is declare an integer int. So this is declare an integer default for r as a s. So r is also used as a s, that contains one we can say the one SQL statement that is given, and then there is a do loop and there is a end for loop. The program fetches the query result one row at a time into the for row. So how this will be going to the different rows? By using the arrow keys, by using the result, by using the any method that is used that is available in the for loop, that will give to the table one row at a time. The statement leave can be used to exit the loop, while iterate starts on tuple next tuple from the beginning of the row, skipping the remaining conditions or statement. So whatever the scope, whatever the condition that will be given, that is given by the beginning and the ending of the loop. The conditional statement that is supported by the SQL also includes the if then else statement. So the condition expression that is also available, that is sorted out, that is also known as the if then else statement. So if there is a boolean expression, then statement or compound statement, then else if there is a boolean expression, then statement or compound statement. Then there is a else then statement or the compound statement. This is one of the example, that is register a student. That is register a student after ensuring classroom capacity is not exceeded. Return a 0 on the success and the -1 if the capacity is exceeded. So if the capacity is exceeded, it will give the output as a 1. This is one of the function, that is create the function register student, that is for registering of the students. Then in SID, that is putting the column field as the SID, and there is a varchar of the 5. Then S course ID, so one is a simple the course ID, that is the ID of the instructor. Then the in SID, that is the varchar 5. Then in S underscore course ID, that is a varchar 8. Then in security ID, then in S semester, S year, that is also numeric. And then out, what is the out? That is outing the error message. So whatever the taking up, that is like the scanner, that is done by the in, and whatever the displaying, that is done by the out. Then there is a return integer. Then there is a begin, then declare the current enrollment list, that is declaring the one variable, that is the current enrollment list. Then select count star asterisk, that is selecting all the fields into the current enroll from the table text, where the course ID equals to s underscore course ID, and the SC ID or section ID equals to s underscore section ID. Then limit the int, then select the capacity to link. Now check the condition, the current enrollment is greater than or less than limit, then begin insert into take values, then return 0, otherwise the section capacity limit already reached. This is the non-standard syntax for procedures and the functions that is also used. Then the next is external language routines. That is, what are the various external languages routine that is available. So this is the topic that is given, that is 5.3, that is the external language supports. So although the procedural extension that is given to the SQL can be very useful, but unfortunately they are not supported in a standard way across database. So it is not supported by the standard way that is available in the database. So it is not supported by the standard across the database. Even the most basic feature have a different syntax or semantics in different database products. So many different objects, many different features have a many different semantics, rules, regulation, procedures. We can say the semantics that is given in the different database products. As a result, programmers have to essentially learn a new language from each database product. So whatever the external languages that is available, so an alternative is gaining support to define the procedure in an imperative procedure language, but allow them to be invoked from the SQL query and the trigger definitions. SQL also allows us to define the functions in the programming languages such as Java, C++, C program. Functions defined in this fashion can be more efficient than the function defined in SQL. So whatever the function that is defined in this manner can be more efficient than defined in the SQL. Then external procedure and the function can be specified in this way that depends on the specific database system. This is one of the, we can say, the example that is given. Now next is the triggers, that is the next topic. That is the next concept. So we are finished with the functions and the procedures, and the next is triggers. So I'm not going to start right now. First of all, let's take a break. Today I'm going to take the break earlier because this is a new topic. So let's take a break right now, then move to the next topic, that is the triggers in the next after the break. So let's take a break, that is the triggers. So come back from the break. Now let's start the session again. So the next topic, that is the triggers. That is what is the triggers and how the triggers will be used. So we have covered with, or we have finished with the functions and the procedures. And the next is what is the trigger, how to use the trigger, what are the various benefits of the triggers. So a trigger is a statement that the system executes automatically as a side effect of a modification to the database. So whenever I do any modification to the system, or any modification that is done, that is automatically, that makes the impact on the database, that is a trigger. So a trigger is a statement that the system executes automatically as a side effects of a modification to the database. So if I want to modify any database, that executes, or that is a statement that executes automatically as a side effects. To design a trigger mechanism, we must need two requirements. So if there is a requirement to design the trigger statement so that the automatically updates will be available automatically in the modification of the database. So whenever there is a designing the trigger mechanism, or to design a trigger mechanism, we must need the two requirements. So there are two requirements that must be met when we use the triggers. First of all, specify when a trigger to be executed. That is, specify which trigger, or when the trigger, what is the duration, what is the timing when a trigger to be executed. This is broken up into an event that causes the trigger to be checked and the condition that must be satisfied for the trigger executed to proceed. That is, specification of the trigger that is to be executed, that is broken down into the event as well as the condition. What is the event that causes the trigger to be checked? So what type of trigger that will be used, and the condition that must be satisfied for the trigger execution to proceed. That is what is the event, what is the condition that is available. Event means the we can say the scenario that is used, and the condition is the condition we give, that is this is, if this is true then this will be satisfied, if this is not true then this will not be satisfied. The condition that must be satisfied for the trigger execution to be proceeds. Then specify the action that to be taken when the trigger executes. So also specifies the action. So first is specify when the trigger to be executed, and then specify the action that is to be taken when the trigger executes. That is the, what are the various actions that must be followed while the trigger is executing. So once we enter a trigger into the database system takes on the responsibility of executing it whenever the specified event occurs. So whenever the specified event occurs, it will correspond or it will execute and the corresponding condition is satisfied. So these are the two scenarios. That is, once we enter a trigger, the resulting system takes the responsibility of executing it whenever the events occurs. That is, this we have specified the trigger that is to be executed, then whenever the event occurs and the corresponding condition is satisfied. Now next is need for the trigger. That is, what is the need of the trigger. So triggers can also be used to implement certain integrity constraints that cannot be specified using the constraint mechanism of SQL. So trigger can also be used to implement the certain integrity constraints. So there are also integrity constraints that is also available, or that is also done, or we can also be implemented by using the triggers. So triggers can be used to implement the certain integrity constraints that cannot be specified using the constraint mechanism of SQL. Triggers are also useful mechanism for altering the humans or for making the certain task automatically. So if I want to apply any task, if I want to alert the humans or start any task automatically when the certain conditions apply, that is done by the triggers. As an example, we could design a trigger that whenever an tuple is inserted into the relation, that is a text relation, update the tuple in the student relation for the student taking the course by adding the number of credit for the course of the total, or the total student total credit. So this is the condition, that is whenever any tuple is inserted in one relation, that makes an impact or that makes the updation in the another relation, that is for the student that taking the course by the relation tables. So as an example, suppose a warehouse wishes to maintain a minimum inventory of each item when the inventory level of item falls below the minimum level. So an order can be placed automatically. So whenever any event can be made automatically by specifying the timing, by specifying the issue that is available, that is done by the triggers. Note that the trigger system cannot be used to perform updates outside the database. Now, what is the uses of triggers in the SQL? That is how the triggers can be used in the SQL. That is the triggers in SQL. So we now consider how to implement the triggers in the SQL. The syntax we present here is defined by the SQL standard, but most database implement non-standard versions of this syntax. So the syntax that is present in the SQL, that is given by the SQL standard, but most of the database implement the non-standard versions of this syntax. Although the syntax we present here may not be supported on such systems, the concept we describe are applicable across the implementation, that is how to implement the trigger. Figure 5.8 shows how the triggers can be implemented. This is how to maintain the trigger that will be discussed after the theory. So figure 8 shows how the triggers can be used to ensure the referential integrity on the time slot ID attribute of the section relation. So one is the relation, that is a section relation, that is how to implement the time slot ID. So let's see first of all, then this is the definition. So this is a create the trigger that is a time slot check 1. So there is a trigger that is allotted. What is the name of the trigger? That is a time slot check 1 after insert on section. So after insert on section, we have to check the trigger. This is the condition that is given, that is a time slot check 1. Then referencing new row as end row. So reference new row as a end row. For each row, that is for each row, it is the condition when end row time slot ID not in, select time slot ID from the time slot that is not present in the time slot, then begin the rollback end. Then begin with the rollback and what is the end procedure that is given. Then create the trigger that includes another trigger, that is a time slot check 2 after delete on time slot. Then referencing the old row as a O, that is the old row, that is the O row for each row when O row dot time slot ID not in the select time slot ID from the time slot. This is the condition, these are the triggers that is available. One is the time slot check 1 from the time slot, one is the O row time slot that is available. Then begin, rollback, end. So to ensure the referential integrity, we would also have to create the triggers to handle the update to the section and the time slot ID. We describe next how triggers can be executed on the updates. So this is the trigger that is given. This is the explanation. The first trigger definition in the figure specify that the trigger is initiated after any insight on the relation section. So if there is any insight, if there is an insight on the section, that will be trigger, that will be rollback, that will be used as a confound statement. Therefore, any transaction that violates the referential integrity constraints get rolled back, ensuring the data in the database satisfied the constraint. It is not sufficient to check the referential integrity on the insert alone. We also need to consider the updates of the section as well as the deletes and the update to the reference table time slot. The second trigger that will be used, that is the case of the delete of the time slot. This trigger checks the time slot ID of the tuple being deleted is either still present in the time slot, or there is no relation, or there is no tuple in the section that causes the time slot ID. So to ensure the referential integrity, we will also create the triggers to handle the section on the updates in the time slot. We describe how the triggers can be executed on the updates, but leave the definition of this trigger on the exercise. These are the various, we can say the update that is available, that is how to use the update or how to use the old row as well as the new row. This is again that one of the, we can say the one of the example that is given of the triggers. These are the various examples of the triggers, that is how to apply the various inventories, how to use the various conditions that is given by the triggers. Now next is when not to use triggers. So what is the scenario when not to use the triggers? What is the basic condition that is not to use the trigger? So there are many good uses for the triggers, such as those who have just seen in the section 5.3.2, but some cases are best handled by the alternative techniques. So we would implement on the on delete cascade feature of foreign key constraint. So there is a foreign key constraint. I'm just coming within 2 minutes. So next is when not to use a trigger, that is what is the condition when not to use the triggers, right? So there are many good uses for triggers, such as those that we have seen in the figure 5.3, but some uses are best handled by alternative techniques. That is when to note the user that are the best alternative techniques, that is when to note to use the triggers. For example, we could implement the on delete cascade feature of foreign key constraint. So whenever we use the on delete key feature, whenever we use the delete cascade feature that is of the foreign key constraint, we could implement a trigger instead of using the cascade feature. Not only would this be the made work to implement, but also it is a very difficult or harder for a database user to understand what are the various set of constraints or what are the various constraints that is available in the database that is implemented in the database. As another example, triggers can also be used to maintain the materialized views. So for example, if we wish to support many very fast access to the total number of students registered, we would try to create the relation this one, that is a section registration, that is a course ID, section ID, semester, year, and the total student. That is defined by the query, that is select the course ID, section ID, semester, year, count ID as a total student from the table takes, that is grouped by the course ID, section ID, semester, year. So this is here the group by clause will be used by grouping the semester, by grouping the section ID, by grouping the course ID into various forms, into various groups. Right. So the value of the course ID that is given, or the value of the section ID that is given, that is also one of the greatest technology that is given. So for each course that must be maintained, and the updated information must be used by using the triggers on the insert, delete, and or update of the text relation. Such maintenance may require the insertion, updation, or deletion of tuples from the section registrations, and the triggers must be written accordingly. However, many database systems now support materialized view, which are automatically maintained by the database system. That is, automatically it is supported by the database systems. As a result, there is no need to write the trigger code for maintaining such materialized view. Triggers have not been used for maintaining the copies or the replicas of database. So triggers have been used, also been used for maintaining the copies, or we can say the replica, that is a duplicate copies of the database. A collection of triggers on the insert, delete, or update can be created on each relation to record the changes in the relations known as the change or delta relation. A separate process copies that is also available over the change to the replica of the database. So if there is any change in the database, that changes must be reflected into the database. Modern database systems, however, provides built-in capability or facilities for database replication, making the managers or making the, we can say the triggers, unnecessary replications. Another problem that is occurs, or what are the various in this session we see what are the various limitations of the triggers. So the another problem that is also used with the triggers lies in the unintended execution of the triggered execution when data are loaded from a backup copy. So whenever the triggers are loaded up into the backup copy, that will be executed by the trigger definition, or when database updates at a site are replicated on a backup site. In such cases, the triggered actions have already been executed and typically should not be executed again. So when the loading the data, triggers can be disabled explicitly. So for backup replica system, they may have to be take over from the my primary systems. So these are the various limitations that is used for the we can say that used with the trigger. So there is one also limitation, that is a replication, that is a duplication can also be used, or duplication can also be made automatically when the replica will be used. That ensures that they are not executed on the backup sites during database replication. Other database systems also provides a system variable that denotes that the system or database is a replica on which the database actions are being replayed. Then triggers should be written and with the great care. So we have to write the triggers with the great care, since a trigger error detected at runtime causes the failure of the action statement, then set of the triggers. Trigger can also serve a very useful purpose. So trigger can also serve a very useful purpose, but they are best avoided when alternative exists. That is, triggers can be used very efficiently, but they are avoided when any event occur, or when any statement occur that can be avoided at a time. Okay, Joseph, you're given the assignment, all right, but they are best avoided when the alternative exists. Many trigger applications can be substituted by the appropriate use of the stored procedures. Now, next is the recursive queries. That is, what is the recursive queries, or what are the usage of recursive queries? And one more thing, to all of you, Joseph and Danelda, you are the two attendees. If you think that this is too much for today, you can tell to me, you can ask to me, you will talk to me that it is enough for today, and don't go further, because if you are not able to understand the concepts, it's no use to do the or study the concepts. So if you think this is too much, then it's okay. Otherwise, I will continue. So whenever you feel this one, you will ask, you will continue, or you will talk to me. So next is the recursive queries. So what is a recursive query, and what are the various recursive query that is used? So consider the instance of the relation prerequisite, that is shown in the figure 5.12, containing the information that is available, or containing the information about the various courses that is offered at the university and the prerequisite for each course. Suppose now that we want to find out which courses are a prerequisite, whether directly or indirectly, for a specified course, say CS 347. That is, we wish to find a course that is direct prerequisite for CS 347, or is a prerequisite for a course that is a prerequisite for the CS 347, and so on. So this is just a scenario that is used. So the transitive closure of the relation prerequisite is a relation that contains all the pairs, that is the CID and the pre. That is, pre is the direct or the indirect prerequisite of the CID. These are the numerous applications that require computation of the similar transitive closures on the hierarchy. So what is the transitive closure that is required, that is done, or that is available on the relation? For example, prerequisite, that is a relation that contains all the pairs, such as the pre is a direct or indirect prerequisite of CID. For example, organizations typically consist of several levels of organizational units. Machines consist of parts that in turn have subparts. So machine can also be of parts that can have subparts that is available, and so on. For example, a bicycle can have subparts such as wheels and the pedals, which in turn have subparts such as tires, rims, and spokes. So transitive closure can be used on such hierarchy to find what are the various parts of the database, or what are the various parts of the relation, that is the hierarchy of the table or hierarchy of the relation. Now next is the transitive closure using the iteration, that is how to apply the or how to use the or how to see the various parts using the iteration, using the looping. So one way to write the above query is to use the iteration. First find those courses that are a direct prerequisite of CS 347. So find out the courses that are or that have a prerequisite that is available with the CS 347, then those courses that are a prerequisite of all the courses under the first set, and so on. This iterative process continue until we reach an iteration when no courses are added. So this iterative process continue to run until we reach an iteration where the no courses are added. So when the addition of the courses finished, so we stop over there. Figure 5.13 shows a function that is a find all prerequisite CID to carry out the task. This function takes the course ID and so on, so on, so on. The procedure contains three temporary tables. Now what is figure 5.13? This is the finding all the prerequisite of a course. So first of all, create a function that is a find all the prerequisites CID varchar. So this is find all the courses that are a prerequisite for CID. Then return table, that is a course ID varchar 8, that is a prerequisite specifies which course is directly a prerequisite for another course. Then begin, that is beginning with the table, that is create the temporary table, that is a prerequisite. Then create a temporary table, that is a new C prerequisite. Then create a temporary table, that is a temp, and that contains the course ID as well as the varchar, that is table temp is used to store the intermediate results. Then insert into table that can also be created, that is used to make the queries, that is done by using the varchar, that is insert into new C prerequisite. Then select prerequisite ID from the prerequisite table where the course ID equals to CID. So whatever the course ID that is available, that is equals to the CID. Now what is a repeat? Repeat means the same condition will be applied, that is insert into the C prerequisite, select course ID from the new C prerequisite, then insert into temp, then select, that is the selection of the procedure can be take place, that is select the prerequisite table, that is how it is used, then making the queries or making the capabilities, that is how prerequisite table will be maintained. Then insert into temp, that is the temp, inserting into the temp, then select prerequisite course ID, that is applying the course ID into the prerequisite from the new prerequisite ID, that is the new prerequisite ID that is given, where the new C prerequisite course ID equals to prerequisite that is equals to the course ID, that is the ID will be matched with the ID. Then delete from the new prerequisite. In the same way, there is a deletion in the new C prerequisite, again inserting into the prerequisite. Now apply the condition, that is the select all the fields from the temp, from the relation temp, then delete from the temp until not exists select star from the new C prerequisite. Then there is the end result. So this is the condition that will be applied, that is how to exist or when to access the database from the new C prerequisite. So this is the 5.13 that shows how to use the prerequisite and how to make the prerequisite. That is repeating the same loop, or we can say the iteration, that is the same loop will be repeated, or the repeat loop exists. First of all, add the courses, then delete the courses, then replace the courses. The same procedure will be repeated again and again and again. Figure 5.14 shows the prerequisite that would be found in each iteration if the procedure were called for the course named CS 347. We note that the use of the except clause in the function ensures that the function works even in the abnormal case when there is a cycle of the prerequisite. For example, A is the prerequisite for the B is a prerequisite for the C is a prerequisite for the A. So there is a cycle, there is a looping. One is depend on other is depend on another is depend on another. This is the prerequisite for the various conditions. So while cycle may be unrealistic in course prerequisites, cycles are possible in other applications. For example, suppose we have a relation flights, then says what cities can be reached from which other cities by a direct flight. So we can write the code that is similar to the find all prerequisite function to find all the cities that are reachable by a sequence of one or more flights from a given city. Or what we have to do is to replace the prerequisite by a flight and replace the attribute names correspondingly. In this situation, there are some cycles, there can be a cycles of reachability, but the function would work correctly since it would eliminate the cities that have already been seen. Now, but how the recursion, or recursion means the same condition will be applied again and again. So how the recursion will be maintained in the SQL. So it is rather convenient to specify transitive closure using the iteration. There is an alternative approach that is using the recursive view definition that is easier to use. So we can use the recursion function to define the set of courses that are a prerequisite of a particular course. Say, for example, CS347 as follows. The courses that are a prerequisite of CS347 are. So what are the various courses? So courses that are prerequisite for the CS347, courses that are prerequisite for those courses that are prerequisite for CS347. Note that 2 is a recursive since it defines a set of courses that are prerequisite of CS347 in terms of the set of courses that are a prerequisite of CS347. So these are the various recursive statements, that is how to use the recursive query. This is the recursive, that is the same statement will be applied again and again and again. That is also known as a monotonic. Now next is advanced aggregation function, that is what are the various advanced aggregation function that is available, with the SQL, or that is available with the we can say the database connectivity. So I'm not going to start this topic right now because this is too much. We have covered almost the 5 topics in the today's class, and this is advanced SQL, not the basic SQL. This is advanced SQL. So please read it carefully 2 or 3 times so that your concepts are clear. And if there is any doubt, you can ask from me. So in the next class, I am taking your next topic, that is the advanced aggregation features. That is what are the various advanced aggregation features. So thanks a lot everyone for listening me, and that's all for today's session. So please read it out, and if there is any doubts, you can ask from me. So thanks a lot for everyone. Bye bye everyone.